Good morning, students. Today we are going to start with one new topic, that is vertical motion. So this topic is most important in all type of competitive exam. Now you consider there is the point. Now we are placing one mass. That is the fixed point. Here only moving point. So here only I consider the mass. Now due to some external force, we are going to move in a circular motion. That is only vertical circular motion. Now we consider the point A here and the point B here, the point C here and here D. So we want to calculate what about the velocity in each point and tension. So now we are consider at a point here the mass will move. So here what are the forces are acted in the mass. Towards the center the tension forces acted. Away from the center, that is centrifugal forces are acted, that is mv squared by r, and one more force are acted, that is the gravitational force. But we want to calculate tension which is equal to what are the forces. So in the way we have to consider, here it is moving particular angle theta, so here also the theta. So now we are considering two components, one is cos component, another one is sin component. So which one is cos component? So this is only cos component because here only we know the angle. So that is why mg cos theta here it is acted. Here mg sin theta is acted. According to the law of equilibrium, we can equate centripetal which is equal to centrifugal. So tension which is equal to, here what are the forces are acted outwards? One is mv squared by r, another one is mg cos theta. Now with the help of the relation you can easily to calculate what about the tension in each point. So here what was the angle? 0 degree. Here what is the angle? 90 degree. Here what is the angle? 180 degree. Here what is the angle? 270 degree. So if you substitute, you can easily to calculate what about the tension. And in this point, what about the tension? So always I told that is what tension is acting towards the center, because here only the string is there. So but here at the point C there is no more tension, only gravity is acted, that gravitational force only, here tension force. So in that situation how you calculate the velocity? Gravitational force mg, one more force acting outwards, that is what? Centrifugal force, that is mv squared by r. We can take that point as C, so that is right. Now we can cancel this. So velocity at C squared which is equal to what? Rg. Then velocity C means you can take root. So root Rg. Now at point A what is the velocity? At point A, simple thing, you have to consider the energy conservation. The reason is what? From A to C it is moving. So the moving body here, kinetic energy converted into potential energy. So you already studied in work energy theorem. Okay. So now we are going to apply conservation of energy. At point A, we have only kinetic energy. Why not potential energy? Here 0. There is no more height. So there is no more potential energy. But at point C, we have what? What is the kinetic energy? And also we have potential energy. So we have both at point C. So now we should calculate what is the value of velocity here. So kinetic energy 1 by 2 m va square which is equal to kinetic energy at point C, that is what? 1 by 2 m. Velocity at C squared, that is only Rg. Potential energy is what? Mass into gravity into height. So the total height from A to C, that is what? 2r. This is the radius. So that is why we are going to consider 2r. Now common term you have to cancel here. you take mass common, so you can cancel. Next one, here you take LCM, that is 2 here, so here only Rg, but here already 2, so 2 into 2 4, 4 plus Rg, that is, so here you can write 4 Rg, 4 Rg plus Rg, that is 5 Rg by 2, this is 1 by 2 Va square, this 2 get cancelled, so Va square, which is nothing but 5 into R into G. Similarly here V at A, which is equal to what? Root of 5 Rg. So where I am getting maximum velocity? At point A. Here what about the least velocity? At point C. Next we should calculate what about the velocity at point B. So we know here velocity at A. Here also you can consider energy conservation. So energy conservation only you can use to solve the numericals. Okay. So now you consider here at point A we have kinetic energy, and at point B both kinetic energy at point B, then potential energy at point B. Kinetic energy, that is what? 1 by 2 m Va squared, that is 5 Rg. Here kinetic energy B, 1 by 2 m Vb squared. What is the potential energy? The height is R only. So mg R only. All mass common, you can take cancel. So now you can take LCM in the right side. Here 2 is common. Here Vb square. Vb square. Here you take 2 means what? 2Rg. This is 1 by 2 5Rg. 2 get cancelled. So Vb square, which is equal to what? 5Rg minus 2Rg. So Vb square is nothing but 3Rg. So V at point B is nothing but root of 3Rg. Then V at point D also same thing only. The reason is height from C to D, H only, same thing only. So this is the way you are going to calculate the velocity in each point. Then tension, I already told, in each point if you substitute the angle, you can easily to calculate. Thank you. Okay students, now we are going to start to solve one numerical. This year they are asking. So first you read the question. In case of vertical circular motion of a particle by a thread of length r, if the tension in the thread is 0 at an angle 30 degree. So here this is only the condition. So at this point only the tension they are saying 0. So here only tension 0. At the cases they are asking what about the velocity here? The velocity of A, that is what? Generally we are saying velocity at A which is equal to root of 5Rg. But which situation that is at tension point here? But they said here that is tension 0. What about the velocity? Now you use resolving the components. Now here what forces are acted in this way? Centripetal force, that is mv squared by r, and here one more force is acted, that is what? Mass into gravity. So now you take the component here, so that is why in this way. What about the component of gravitational force? mg cos theta. Why? Because this is only, but due to the angle it is moving like here. So now this component is mg cos theta. Then you can use what about the theta value here? So up to here the angle is 90 degree. Here we have one more 30 degree. So theta value here 120 degree. Now you applied law of equilibrium. So now you see here left side force tension, right side force, that is what? mv squared by r plus mg cos 120 degree. Now the condition is what? Tension become 0. So now you substitute the value mg cos 1 and 120 degree, that is minus 1 by 2. This will move to left side. So plus 1 by 2. So mg by 2, which is nothing but m into v squared by r. Mass get cancelled. So v square at point B I have to consider here. So VB square, which is equal to what? RG by 2. Sir, why we should calculate velocity at point B? They are asking A only, But here, how you calculate with the help of energy conservation? So, at point A, we have only kinetic energy. The reason is there is no more height. Then what about the at point B? We have both energy. One is kinetic energy as well as another one is potential energy at a point B. So in A, potential energy becomes 0. So now potential energy at B means we should calculate what about the height. So you calculate the height. So at point B, from here the total height is, this is only total height, but I don't know this value. So how you calculate? You can use this angle 30 degree. We know this is only the hypotenuse side, radius r, small r, that is only they are given in the numerical. So you can use here small r. So with the help of this, you can calculate means sine 30 degree is nothing but, this is you can consider h dash, opposite side h dash, then hypotenuse, that is what? R. Sine 30 1 by 2, this r moves to here, so r by 2 only h dash. So finally, what about the total height at point B? R by 2, and here to here r, so plus r. You take LCM, that is 2r plus r, 3r by 2, that is height at point B. Now you have all the data. So now you can use the energy conservation. First one, 1 by 2 m VA squared is equal to, what about the kinetic energy at point B? 1 by 2 m VB square, that is what? This is only. So RG by 2 plus potential energy, that is what? M into G, H value 3R by 2. Now you take all we have in denominator 2, you can cancel, then mass also you can cancel, then remaining, that is what? VA square, which is equal to here RG by 2, so RG by 2, then here plus 3RG. Now you take LCM, so here 2 into 3 6, 6 plus 1 7, 7RG by 2, so VA square. So we want to calculate VA means you take root on this side, so 7 by 2 RG. So this is only velocity at point A. So you have to read the question once or twice, then based on the condition only you give the answer. Thank you.